let's look at the homework from 2.1. Hopefully this is something that you didn't find too difficult. Step 1. So we have the region is here, the two curves that we have to talk about is x cubed plus 3x and y is 4x. Now you can make a picture and you see what goes on. And you'll see, well, the last one is a line, right? So, but let's do this algebraically. So the first thing is the intersection points, and that's obtained by just equaling these two expressions and then solving. That's x cubed minus x equals 0. We have the factor, we have an x and then x squared minus 1, so that is x times x minus 1, then x plus 1. And we get three solutions, x is 0, x is 1, x is negative 1. It's very important that you do not forget any of these solutions. Okay, so be very careful with this x here. Perhaps sometimes you think, oh, I can scratch out an x, like simplify by dividing by x. But remember, dividing by x is a factor, and x could be 0. So you should not do that, right? You really should factor the whole thing and then look at all the possible factors. This is important, especially in the second step, because in the second step we're going to make our table. We need to know exactly what the intersection points are, because we know that nothing changes in between them, but things can change at the intersection point. Can, I'm saying can, it's not sure, but it's possible. So, okay, so what are the two equations? X cubed plus 3x and 4x. So we take test points. It's a bit annoying that we have to take here some fractions. So let's do these two. What did we get? Minus 1/8 minus 3 halves. Okay, and the other one we get minus 2. Right, yes. Okay, minus 1/8 minus 3 halves to see what, okay, you can put it in the calculator and see the decimal expression, but let's just work it out a little bit. What is this? Well, I'm putting on eighths. This is 12 eighths, and so this is minus 13 eighths, right? So we see that is, what is the biggest one here? Be careful, these are negative numbers, so this is the bigger one, because this is minus 1 point whatever, and this is minus 2. Okay, so the bigger one on this interval, this is the top one. What happens at the other one is 1/8 plus 3 halves, so that would give me, let's see, 13 eighths. Okay, and in the bottom I will get 2. Now, what is the bigger here? 2 is the bigger number. Okay. All right, so we know now step 3. I'm going to write this here so that I have everything inside. We have to put down the integral, or rather that gives me the area. So we have two parts. We're going to have from minus 1 to 0, and then from 0 to 1. And in the first one we have to put this one on top, so x cubed plus 3x minus 4x dx. Plus, and in the second one it's the other way around, so it's 4x minus, and be careful when, especially when you're subtracting expressions, that you don't make minus signs mistake, right? So what we get is from minus 1 to 0, x cubed minus x dx plus from 0 to 1, and that would be 4x minus, so it's minus x cubed, and then we have 4x minus 3x, so that is plus x. And again, you see that these two things are almost the same except for the negative side. Okay, quickly. And the driving, x to the 4th over 4 minus x squared over 2 between minus 1 and 0, plus minus x cubed plus x between 0 and 1. Okay? Oh, I just copied the thing here instead of integrated it. Okay, so of course that is the same. We would have minus x to the 4th over 4 plus x over squared over 2. Okay, we plug everything in. We get in here, we plug in, this is the top point, so we have to plug in 0 first. So 0 minus, now we plug in negative 1. These are all even powers, so we get 1/4 minus a half. Plus, now we plug in 1, that minus 1/4 plus a half, and then we plug in 0, that is 0. We subtract, right? Remember. And each of these two terms actually, because each of these represent an area, right? So each actually, I'm saying the total thing has to be positive, but even each of them has to be positive. So let's make sure that is the case. What is this? 1/4 minus a half is minus 1/4, but there's an extra minus here. So this whole thing is 1/4, and this is also 1/4. So the whole thing is equal to 2/4, it's a half. Okay? The next one, that was number 28. Yeah, the question might be a little bit misleading here, what it was saying. There's one topic, one part I didn't cover if you perhaps looked at the textbook, and that is integration along the y. I'm not doing that, we stopped doing that, so I'm ignoring that. Okay, so whatever the question was asking, this particular thing didn't concern this particular question here. We had y is x to the 6th and y is x to the 4th. Okay, so that's again a region given by these two things. So step 1, where are the intersection points? Let me write down what it is. Step 1 is intersection points. So x to the 6th equals x to the 4th. Be careful. You might have the temptation to cancel out x to the 4th. But then you forget that x equals 0 is a possibility, in which case you could not cancel, right? So never do that. Try to always factor. And the factoring is always by putting everything on one side. Now you can factor out the x to the 4th. Okay? And so this is now x to the 4th, x minus 1, x plus 1 equals 0. Now put each of these factors equal to 0. Now x to the 4th equal to 0 is the same as x equals 0. When a power is 0, then the thing itself was 0. So this gives you x is 0, this gives x is 1, and this gives x is negative 1. We're basically back in the same points as before, but of course it's a different function, so we should see what happens in our table. Okay, it's not so bad here, right? Rather easy equations, x to the 4th and x to the 6th. Oh, I'm saying one thing and I'm writing both the same. Okay, and so the minus 1, 0, 1. Important here is that you have it in right order. Okay, so minus 1 has to be the smallest one, so it comes first. Okay, I'm going to take points in between here. Let's take minus 1/2, and here a half. It has to be in between, right? I cannot take 0 or something like that, or 2 or something. That gives me the wrong information. Okay, plug it in. 2 to the power 6 is 64, right? So it's minus 1 over 64. No. Plus, right? Sorry. It's an even power. Sorry, it's 1 over 64, and this would be 1 over 16. Now, that is the bigger number. And if I plug in a half, well, I get the same result, the same numbers, right? Because it's even powers. And so this is still on the top. So here we have a situation where on both intervals, the same one is on top. Now we can split it still in two parts, but it's actually not necessary. So while step 3, while in general you would split it into this integral and this integral, since we have to put the same function in there, we can combine them. So it is quicker to now just say from minus 1 to 1, x to the 4th, that's the top one, and x to the 6th is the bottom one. Put differently, on this whole interval from minus 1 to 1, we know that this is the top curve. Okay, and so this will give me x to the 5th over 5 minus x to the 7th over 7 between minus 1 and 1. So that was 1/5 minus 1/7 minus, now I put in negative 1 here, so these are negative powers, minus 1/5 minus plus 1/7. And so this all together is 1/5 minus 1/5, so I get 2/5, and then minus 1/7 minus 1/7 minus 2/7. Now just to double check that this is something that is positive, to put everything common denominator 35, then we have 14 minus 10, so we get 4/35, which is a positive number. And in fact, each of these things are positive, as we already said. No, sorry. Scratch that very last remark. It had nothing to do with what I was saying, because we had only one integral. Okay, sorry. All right, and then the last one, that was number 33. 33, same question, so ignoring whatever this was saying about this y integration, we completely ignore that. And then the other one was, x cubed minus 2x squared minus x plus 2. Okay, and step 1, intersection points, put them equal to each other. Okay, so the 2's cancel here, but we should bring everything on the same side. I always like to put everything on the side where the highest degree is positive. So this one here. So to bring the x squared to the other side, it becomes minus 3x squared, right? I hope you see this. I'm not, okay, if you want me to do this, right, so this, you do minus x squared here, minus x squared here, and you get minus 3x squared, okay? Same here, you do plus 3x, you do plus 3x, and you get plus 2x, okay? And you do all this thing, and the 2's we already cancelled out. Again, we have a factor x here that we can factor out. That's x squared minus 3x plus 2. And now we need two numbers that multiply to 2 and add up to negative 3, which is the ones I did here. Okay, so we get solutions. X is 0, x is 2, x is 1. And step 2, the table, we have to put them in order. So be careful, now the order is 0, 1, 2. Okay, and so our equations are x squared minus 3x plus 2 and x cubed minus 2x squared minus x plus 2. And yeah, not much choice. I have to take fractions always. Okay, of course you can take decimal numbers and put it in your calculator, right? If you want to, remember what you can always do is in your calculator, I cannot show it here, but on your calculator you can put this function as in your as y1 and this as y2, and then you can make a table and you can ask whatever number you want to put in there, and then it will just spit it out for you. But these are so easy numbers that I like to do it by hand. So it's 1/4 minus 3/2 plus 2. We should put everything on common denominator. I'm going to do this here. Common denominator 4, so 1/4 minus 6/4 plus 8/4. So this is 9 is 3/4. Okay. Is that right? Yeah, okay. So what is the other one? Okay, we get 1/8 minus 2/4 minus 1/2 plus 2. So put in common denominator 8. I get 1 minus 4 minus 4 plus 16. Oh, yeah, right. That's correct, right? Yeah, this has to be on the denominator 8, right? So that is 9/8, right? Yeah. Now that's bigger than 1, and the other one is smaller than 1, so this is the bigger one. Okay. Now what's happened in the other one? We get 9/4 minus 9/2 plus 2, so that's on the 9 minus 18 plus 8/4. That is 17 minus 18, so minus 1/4. And then, okay, I'll do a different color that you see that where I'm counting. So we have now 3/2, so 27/8 minus 18/4, right? 9 squared times 2 is 18, 4, minus 3/2 plus 2, put this all in common denominator, 27, minus 36, minus 12, plus 16 over 8. And this is, okay, what we have here, that is 27 minus 36, that is negative 9, negative 21, negative 5/8. It's negative 5/8. So, well, we have to compare these two numbers, so it's better to put them also on 8, so it's minus 2/8. Now, which is the bigger? This is the bigger, right? Minus 2/8 is a smaller number than it is bigger number than minus 5/8, because in absolute value it's smaller. That's what I meant to say. Okay, that's kind of often what we see, that we have switched around, but as we notice that this is an example where we didn't switch around. Okay, so you cannot make this conclusion. You just have to always work it out. Okay, so step 3, our integral from 0 to 1. We're gonna take this guy is the top one, so I get x cubed minus 2x squared minus x plus 2, and from that we subtract x squared minus 3x plus 2 dx, plus, and now we go from 1 to 2 and we do the other way around. So x squared minus 3x plus 2 minus x cubed minus 2x squared minus x plus 2 dx. If there's so many sums and things that you're subtracting, it's sometimes better to take your time so that you don't make mistakes. So I'm gonna just expand. I'm distributing the negative sign there as minus x squared plus 3x minus 2 dx, okay? And then I can take like terms together, right? So that plus, and here I go from 1 to x cubed. I'm gonna try to put it all in the same thing. X cubed minus 3x plus 2 minus x cubed. Oh, this was x squared. Minus x cubed plus 2x squared plus x minus 2 dx. So let's see. The 2 cancels with the negative 2. We get x cubed minus 3x squared. These are these guys. And then we have a minus x plus 2x. No, sorry, I'm looking wrong. Minus x plus 3x, that's plus 2x dx. See, I kind of have to. What is this? Well, this is also the equation that we use, right? It must also be the equation or the negative of this equation, because this is just exactly the same thing. Okay. And then the other one is, now we get the signs, just the opposite signs, right? Just double checking this. So we have an x squared plus a 2x squared, so we have a 3x squared, that's these two. Then we have a minus 3x plus x, that is minus 2x. And that's these two terms. The 2's cancel, and I have a minus x cubed dx. Okay, this is exactly the opposite negative signs. Okay, so we get x to the 4th over 4 minus x cubed plus x squared between 0 and 1 plus, and now we have the same thing, x cubed minus x squared minus x to the 4th over 4 between, where are we? Oh, I forgot to write my endpoints here, 1 and 2, right? Double checking, was it 1 and 2, where were my endpoints? Yep, okay. And then you plug in. You have to do this step, you don't have to simplify anymore, but you have to show me that you know how you plug these things in. Okay, minus 0, plus, and here we have 8 minus 4 minus 16 divided by 4 is 4, and now you also plug in 1 minus 1 minus 1/4. Okay, so let's see what we have. These two guys cancel, so this, the first one is 1/4, and this is, well, this also cancels, and then we have this also cancels, also 1/4. Now the fact that these numbers are the same is also coincidence. Well, coincidence, it's also because this thing is rather symmetric. But that's not always the case. I don't know whether we have an example. No, we don't have, because it's sometimes easier to give examples that are somehow symmetric. But again, so whatever this value is has nothing to do with this value. They happen to be the same, but they don't need to be the same. And so the whole thing is then up to 1/4 plus 1/4 is a half. Okay. That's the homework, and so there will also be a review on this, but it's basically the same thing.